Good evening, boys and girls, or good morning, whenever you might find this in your time. I just want to quickly go through this assignment. Before you do this, you should have read the molecules and how we write molecular formulas in the CK12 reading and the review questions. This is related, not exactly following, but the whole point of the lessons is learning how to write those chemicals and how or why we name them what they do. So, there's two kinds of bonding: covalent bonds and ionic bonds, and there's different rules for each of them. We're going to start with the ionic bond. So we call it simple binary. Binary means two ions. That's it. So read through here slowly. Cation, you have to remember what a cation is. See the T, that means think of positive. Whoops. Think of positive. So you have the cation is going to probably come from, let's pause, what side of the periodic table? Right. It should be on the left side. Those are the metals that tend to lose. So think of once again, all your group 1, group 2, and even skip a few, group 3. All of these are closer to having their outer level filled if they lose those 3 electrons, 2 electrons, or 1 electron. And again, remembering that that's how ions are formed. By losing an electron, you're a negative ion, -2 ion. I'm sorry, +1 ion, +2 ion, +3 ion. So don't forget what you've learned up to this point. All right. So now back over here. So ionic compounds are compounds formed by the combination of a cation, that's going to be your metal, and an anion, the negatively charged nonmetal. This has been in the quizzes and exit tickets, so you might need to go back if this is all completely new and confusing to you. We've covered this in the past 3 days. So these are commonly known as salts. You may not have known that, but you know of sodium chloride. Sodium chloride is a salt. Well, there's many salts. Any ionic compound, because of its charges, dissolves very well in water. And when you dehydrate, that is when the water vaporizes, it leaves behind this white precipitate, which is the salt. And that's why it gets its name, salt, in general, for all kinds. So binary ionic compounds contain only 2 elements. That's why they're binary. And here's some examples we're going to go through. We got to remember that the ions have a charge. So when they have opposite charges, they will attract each other, and they attract each other in proportion, as we'll see in this first example. So sodium ion has a +1. Chloride has a -1. Again, sodium's over here in group 1, so it's going to have a +1. Chlorine is over here in the 7, so it has 7 electrons in the valence. When it gains the 1, it'll become a -1. So that's an easy. That's a 1-for-1 ratio, right? So if we look at the positive charge on the sodium and we add the negative charge of the chlorine, we come out with an overall charge of 0. That's what it means by neutral. The net charge is neutral. Okay. So the formula then becomes easy. NaCl. We did this on the worksheets. So we're familiar with sodium chloride, possibly a salt, but notice how I said that. We kept the name sodium. So generally in these ionic compounds, you will always keep the name of the metal: beryllium, magnesium, sodium, lithium. And then the second element named will be the nonmetal over here, but we change it from INE or EN or UR to IDE, IDE. So fluoride, chloride, sulfide, oxide, and so forth. Let's see how that's put into use here. So the formula for NaCl would actually be sodium and then chlor. Change the last letters to ide, and you have sodium chloride. All right, and you notice that we don't have the ones, although you can. It is not necessary. Otherwise, it wouldn't even be there. It would be gone. So the fact that it's written there means there's at least 1. If there's any more than 1, then we put the subscript, like in our example 2 here. For a salt containing calcium ion, now if you see a 2+ here, what group do you think this is in the periodic table? In the second group, right? Because it had a +2, that means it lost 2 electrons. Got to think about that. And again, we're familiar with chlorine. So the chlorine ion becomes chloride. But we notice we have a +2 here and only a -1 here. And that leaves us with an overall positive charge. That positive charge is going to attract another negative, which means we're going to have 2 chlorine for that 1 calcium. Therefore, we have the calcium as a +2 plus 2 -1s, and we have 0. We're neutral, and that's what we need to obtain, neutrality. So the formula is calcium, it only took 1. Chlorine, we needed 2 of them, and so we say CaCl2, just like we learned in the reading. So the nomenclature, what do you call them? So that's how you write it. If you're given the name, that's the formula. So when naming the ionic compounds, you simply write the element name of the metal first, followed by the ion name of the nonmetal, or cation, then the anion. So let's look at one example. You got 10 of them here. You may have to go back and forth. These are just simple binary ionic compounds. So sodium bromide. This will take some time. You'll just come over to your periodic table. You'll search and search for sodium. You find it here in the first group. You have to search and search and search for bromide, there's beryllium, B, boron. So where's B? Oh, there's another Br, bromine. So it's just trial and error. You just have to hunt it down. But now that we found it over here, bromine, it's in the 7th group. So it has 7 electrons. And remember that all elements in the same group have the same features. So just like fluorine and chlorine, bromine will have a -1 charge. And sodium over here will have a +1 charge. So when you have sodium and a bromide, the ionic, how would you write this? Anyone? Anyone? That's right. NaBr.
So hot I can't.
And that's it. Sodium bromide. Now you've continued going down, and don't forget the example here for the calcium chloride. If it has a +2 up here and this is a -1, just think you'll need 2 down here. And that's what they did, the 2 here. That tells me that there were +2 calcium with 2 negative chlorine. All right, so fill in the rest of these using this Cami. When you get down here to the last 10, it's going to go in reverse. Here they give you K2O. Again, go to your periodic table, look for the K, look for the O. What's the name going to be? These are ionic compounds, so the naming is going to be different than the covalent. So you simply say the name of the cation first, potassium, and then the anion with the suffix "ide." So this would be potassium, ox, and then ide. That's it, potassium oxide. All right, so I did one example in each of these. You will go ahead and do the rest, and that's it for today. Tomorrow we will do, we'll go a little more into the reactions, and we'll do the covalent naming. This is called nomenclature. This is how we name the chemical compounds now that we know how they come together. If we all called it something different, no one would know what anyone else is talking about. So this is a systematic way that's been adopted by chemists. All right. Thanks for watching.